Like I said in the last video, it's hard to say where this particular idea is coming from. You know, where do ideas come from? I don't know. Welcome back, everybody. Thanks for watching. I really appreciate it. This is a continuation of the video that I did last week, and I realized the video I did last week was somewhat cryptic, but laying there I had this idea running around my head really strongly, and it was like one of those Roy Neary kind of Close Encounters of the Third Kind sort of ideas that you just can't get out of your head until you do something about it. Being a somewhat creative person at times, you know, I build these electronic things or do other things. Sometimes I'm familiar with this. You get an idea in your head and it's going to keep you awake until you write it down, or if it's a song, until you play it on the piano and write this music out, or in this case, electronics. It wasn't going to leave me alone until I started building this thing. So I came out here to the office. I got these breadboards. I put them together and I started assembling this module. Now this module has 8 VCOs on it, and I will, at some later date, when I know that this thing works, I don't want to start publishing schematics and layouts and things like that, and then it turns out the whole thing is a disaster. That'll just waste everyone's time. But let's see if we can get this to work first. But here's the board. So I had this board made. It's the first board I've ever had made. You know, if you've done circuit boards before, you can laugh at my layout, which is to say it's not very compact. I probably could have got this thing done in, you know, that much space. Would have saved a lot of money. They charge you per square inch when you make a board like this, and I had this done at Advanced Circuits using their production process. I should have went for the cheap process. So these are pretty nice boards. You can see I have the analog ground out here separated from the digital ground, and I'm using just the outline of the Arduino. Now one thing I could have done is actually had the Arduino pads put on this board itself and just soldered my own SMD components on there, and that would have made it probably a little bit cheaper. As it is, it was kind of pricey to do this. These boards were not inexpensive, and here's the final result. So I have 4 of these, and if you wanted to go cost this out, you'd realize that I had done something here that was probably not entirely smart. I was a little bit too fast on the clicker finger to go and buy things. So each one of these boards has 2 Arduino Pro Minis. I got it from SparkFun, so these guys are about $10 a piece. Soldered on in SMD are analog devices 9833 DDS direct digital synthesis modules. This is an LT 1013. And then there's a bunch of passives. These capacitors basically just to filter the power, etc., etc. And then these are the bias for the op amp, you know, to set the gain, etc. So the idea would be that we'll provide power on this end. These guys will be programmed to receive a signal on an input pin and a trigger. So one of these will be for signaling, one of these will be for trigger. And basically, the Arduinos will control the 9833s. We'll choose between square wave, sine wave, triangle wave. Each one of those, these can actually produce sine, square, or triangle at frequencies from, you know, basically DC up to about 25 megahertz. So producing a signal in the audio range is not taxing at all for these things. Right, which is how we're getting the sound out of them. This board is running at 5 volts. Everything on here is running at 5 volts, and the op amp here is just to provide a little amplification and stability for the signal, because the signal is going to have to go out and go to VCAs, VCFs, whatever. But this just provides this local signal conditioning for these two. So each one of these boards has two VCOs on it. And so this is, at least in the beginning, it'll be an 8-voice synthesizer. And I've got a couple. I bought spare boards. I think I bought 10 of them total. Yeah, so there's 6 left here. So I guess if I wanted to make an additional 12 voices, I could. But first, let's see if the darn thing actually even works. Take 2. I guess what I'm going to go through here now is the theory behind this thing. And, you know, is there any synchronicity with, forget that. Take 3. What I'm going to go through now is the theory behind this, the technical theory behind it. We can go over the supernatural theory behind it at some other time, if such a thing exists. So my construction method is this. I'm going to build the individual components first. So the VCO, VCA, VCFs, all those components built first. I want them all to be Arduino controllable. So what this is going to be is an analog synthesizer with a digital control path. So the analog path, the sound path, the sonic path will be purely analog, and the control path will be purely digital, and it'll be programmable via Arduino, which should put it in the range of, in the realm of, anybody who wants to, you know, copy this could do the same thing and program it in their own way. The design should be implementable by anybody, shouldn't need a degree. I'm going to design all of the, it says control first, supervision. I'm going to design, that's not true. I'm going to design the signal path first, the analog signal path first, and then the supervisor, which will handle choosing what oscillator to assign to which note, and which will control setting the envelope generator. And then also we should have a cross-point switch in there to switch between different, switch in different VCFs, VCAs, et cetera, And so I'll do that second. I'll probably also have that Arduino controllable and control it via maybe an Arduino Mega or something. I might need a lot more code. I'm hoping I can use an OLED display, and I probably need a little more horsepower for that. Now let's see. Oh, and all the boards are going to be either plus minus 15 volts. So the signal path will be plus minus 15 volts because most of the op amps that I'm going to use and that I have laying around work best that way. The Arduino path will be 5 volts. So the boards will either be 5 volts or 15 volts. I'll have to create, actually that kind of simplifies things because I'll have a plus minus 15 volt power supply, and then I'll just put a 5 volt regulator in the path, and I'll derive the 5 volts from that. All right, so let's see if this works. Okay, the VCO is, I'm using a single-ended plus 5 volt to ground LT 1013 op amp. So the supply to the LT 1013 is just 5 volts. That's it. It's single-ended. It's going to be Arduino programmable, as you see. I'm using Pro Minis. As I mentioned just a minute ago, I bought the boards from SparkFun. It's an open source design, so I could actually just take that board design and just copy it and have it printed on these boards that I'm making here for myself. And as I am not doing this for commercial reasons, I think I'm well within my rights to do it as long as I give them attribution. I'm only going to ever make one of these, and it's just for myself. I'm using the Analog Devices 9833 direct digital synthesis chip to actually make the sine waves and the triangle waves, and basically to create the frequencies. Signal conditioning, as I mentioned, through the 1013, and then I'm going to control these through the serial interfaces on the Arduino. So on those boards, you saw 2 Arduinos. There's a serial in and serial out that can run at, I don't know, 115K baud, which is probably darn fast enough to receive information about what note to play and for how long to play it, that kind of thing. And each VCO will be conditioned via an envelope generator, and I'll show you that in a minute. Voltage control amplifiers, it's going to be a double-ended plus minus 15 volt board based on the LM 13700 transconductance amplifier, which, you know, is in just about every synthesizer known to man. It's a simple design. I have basically just reproduced the datasheet design, so I didn't do anything with that. This is I've just implemented what came out of their datasheet. Doing plus minus 15 volts from an off-board generator. Of course, I'm not going to, the control signal is going to come from off-board. And this is the control signal for the amplifiers. So I need to come in with an analog voltage that's either minus 15, which will shut the amplifier down, or plus 15, which will be full volume. I've got to figure out how to do that from an Arduino, which only produces pulse width modulation out. I got an idea, and I'll show that later. The envelope generator, which will be used to send control signals to the VCAs and the VCFs, and it'll be 5-volt Arduino based, but I'm going to have to convert it to plus minus 15. And I'm also going to have to take that pulse width modulated output and send it through a digital analog converter. That could be as simple as a capacitor, and you know, I'll when I do the video on the amplifier, I'll show you how that works. And one thing I was thinking of is the actual waveforms, the actual ADSR waveforms, along with the notes and everything else should, you know, basically patches should be storable somewhere. I've got no memory on this thing right now. I'm probably going to have to put it on a thumb drive or something like that. Some kind of, you know, some kind of SD card, something like that. And of course, I've got to have a mixer to mix the signals from all these different things. This is just going to be a very simple double-ended TLO 72 or 82. I don't think it's going to matter which one. And should be able to accept 8 inputs. That's easy to gen up. And maybe it'll be multiplexed. Maybe I'll have a couple of these things. Final output will go to the VCA and control, which will be controlled by the envelope generator. And here's kind of a block diagram, kind of a lame block diagram. I'm thinking that the keyboard, I'm just going to use a MIDI keyboard. So this is going to be actually a module. At least it'll start out a module. The control will come into, you know, let's say an Arduino Mega. And then that will control each of the VCOs, and there'll be 8 of them. I only drew 4 because I was lazy. And then each of the VCOs will talk to a voltage-controlled amp, which will have its own EEG. So there'll be an individual EEG signal for each voltage-controlled amp and each VCO. I'm probably going to mix every 2 of these together. So, you know, there'll probably be 4 mixers. Maybe you know, the thing is, I think about flexibility versus hardware, and I realize that when you go strive for ultimate flexibility in your signal path, you wind up with sounds that just sound like garbage. If you mix too much crap together, it just sounds like trash. So I'm thinking I'm going to mix every 2 VCOs together, which means on one of my boards here, every board like this one will have its own mixer. And let me turn that on, this light on here, so we can see that. So every board, like this one here that I just showed you before, will have its own mixer. And then you say, gee, why didn't you just put it on the board? I don't know, because I did this first, right? One of the things that's going to have to happen is, as we go along, we're going to find that some of the design choices I made early on when I built this, you know, I'm going to wish I had done something different, that I called a different signal out or something like that. What I'm hoping is that by having used the Arduino to control it, that I can get around, you know, design changes by changing the software. We'll see. So VCOs will go into a VCA voltage control amplifier. Each one of those will go into its own, will go into a mixer. So there'll be 8 VCOs, 8 VCAs, 4 mixers, and then a combination of VCFs. I've got a bunch of VCF boards that I'd like to use from my MOTM synth, and I'm thinking I'll switch them in and out, and we'll try different ones, and that'll just be part of the architecture, that these mixers will all coalesce in a VCF somewhere, and then that goes through a final VCA. Of course, the VCFs and the VCAs all have their own EEG, and that'll go to the output. There'll be some kind of cross-point switch, because you're going to want to, you know, one thing to do is just create one EEG and just have a switch that switches it between, you know, each of these different things, or have multiple EEGs and have them switchable. That's possible through, I think, For instance, the cat uses the CD 4016, is that what it is? I think it's a 4016. It's like a transmission gate switch. I've got a whole mess of those laying around. I may just use those to switch things around. So that's the theory in a block diagrammatic view of what I'm thinking now. It's a fuzzy idea. It is not a well thought out process at the moment, which is why I think if I just keep building these modules, that as the idea gels, as long as I've made the modules as flexible as possible, I'll be able to morph the overall design. And just for the fun of it, here's the VCA prototype. What a mess, eh? The perf boards, they're supposed to be simple, but they're not very simple. Anyway, this is a circuit that comes straight out of the data sheet for the LM 13700. And I got a whole mess of these because in building my modular synth, you wind up needing a lot of these guys. So that comes straight out of the data sheet. I've actually sent away for a board to be made that it will be much more compact than this one. Much more compact. And we'll put together 8. Well, we don't need 8 because each one of these has two transconductance amps in them. So we'll make 4 of these to go along with the 4 of these. And each one will have 2 channels. And we'll control it via a EEG generator. And I've got some ideas around that. Let me see if I can bring my... This may not look like much right now, but this is the EEG generator. And I'm actually waiting for a part to show up. Right now, what I'm doing is I'm actually just taking the pulse width modulation output, and if you use a 47K resistor and a 0.1 microfarad capacitor, you pretty much can create an envelope based on the PWM that's coming out of here. Another thing I just thought of is that the PWM coming out of here would kind of make an interesting sound. So maybe I'll take a pulse out of here that we can also use for the music. All I did was I took the signal that came off this capacitor and I'm amplifying it with this TLO 72 here and just looking at it, and it's not too satisfying because it's, as you can imagine, the output of the capacitor is very ripply. You know, it's not a nice sine wave. And I found a device online. I've ordered it from DigiKey. I expect it to show up in a day or two, which basically takes the PWM and creates a very smooth envelope out of it. And that's what I want to use for the EEG for the other circuits. So we'll see how that all works out in a future video. Okay, so with the little microcube amplifying the output of one of these oscillators, and I'm cheating, I've got some delay on there. Now the delay's off. You can see the signal here, you can hear the signal up there, and it's going through 2 octaves of 12 notes. Put a little delay on it, it's a little cooler sounding. But it just gives you an indication of what we'll be able to do in the future with this thing. Hey, so there's the outline of the idea. It is kind of fuzzy in my mind at the moment, and it is gelling, and what I'm hoping is that by building it module at a time, that it'll come clearer as I get more of the pieces together, and we'll see what works and what doesn't work. I will publish the schematics here online. You guys will be able to reproduce it if you want. Right now, I would say probably not worth reproducing because it ain't cheap. Each of those Arduinos is $10. Each of those AD analog devices 9833s are $10. The LT1013s are like $5, so each one of these boards, and then it costs, you know, God knows how much to have the boards made. So each one of these boards is costing me upward of $70. I don't think that's a good design. I think it can be done a lot cheaper, and I would recommend you do it a lot cheaper if you try. But I'll publish. I plan for this to be open source. I'm using open source components, and I'm not going to make any money on this for sure. It's just kind of fun to watch it evolve. Meanwhile, I'll say goodbye to you for now with this shot of my keyboard hero, and you know, thank him for a lifetime of music, and certainly changed my life, that's for sure, and I'll miss him. Okay, thank you all very much for watching, and if you can, I wouldn't mind a thumbs up if you appreciate the work I've put into this, and showing it to you. I mean, I'm going to put the work into it one way or another myself, but it does take some doing to put all this stuff onto a video. And it's actually a lot less lonely knowing it's on a video and you guys can see it, and I get a little feedback from it instead of just building this stuff and putting it in my garage and it never sees the light of day. So I do appreciate you being there. I do appreciate YouTube for letting me publish these things. Have a good one, and see you in the next video.